Welcome to Podkey Slopcast, where AI power, policy, and economics all get stress tested. This set of stories looks disconnected at first, but they all circle the same question. Who gets to control AI when the stakes stop being theoretical? Governments are testing limits, labs are subsidizing adoption, and the hardware layer keeps looking more strategic by the week. The reported White House discussions around an executive order on open-source AI matter, even in rumor form, because they suggest a possible policy turn before any formal rule exists. The core claim is that open-weight models, especially Chinese origin ones, create security risks that aren't handled well by the current export control playbook. That's plausible up to a point. Export controls try to choke off access to chips and certain model capabilities. Open-source models move differently. Once weights are out, they spread, get fine-tuned, and become harder to contain through the old hardware-first logic. But there's a big distinction between saying open models are harder to govern and saying they should be treated as second-class tools across government use. Those are not the same conclusion. If the policy really shifts toward limiting official use of open-source systems, the practical effect could be less about stopping adversaries and more about reshaping legitimacy. Government procurement has signaling power. It tells agencies, contractors, and allies what counts as trusted AI. The contradiction is that open models also offer auditability advantages. Closed systems can hide dangerous behavior, hidden data practices, or unexplained changes behind an API. Open systems create other risks, but they also let independent researchers inspect and stress test them. So, the hard question isn't open versus closed in the abstract. It's whether policymakers can define actual risk criteria that map to misuse, provenance, and deployment context, instead of using open source as a rough political proxy for less controllable or foreign-tainted. The UAE getting advanced AI chips without a license is a concrete policy change and a pretty dramatic one. That kind of access used to be functionally reserved for countries inside a tighter US security orbit. Supporters can argue this is strategic statecraft. If the US wants to shape where global AI infrastructure gets built, preferential access to chips is leverage. The concern is that the Gulf can become an enormous compute hub sitting in a grey zone, closely tied to the US in some ways, but still exposed to capital flows, partnerships, and technical relationships that make downstream control harder. Critics are also alleging corruption tied to reported gains for Trump-linked entities. That is a serious claim, but listeners should separate two layers here. One is whether the waiver has a national security logic, the other is whether the deal was influenced by private financial benefit. Those can overlap, but they need different evidence. The stronger, more substantiated policy concern right now is the backdoor problem. Even if chips do not go directly to China, do they help create a regional cloud and data center base that Chinese firms, talent, or intermediaries can still benefit from? If yes, then the restriction moved from the border to the network, which is much harder to police. The second-order effect is broader than the UAE. Once one non-NATO partner gets this treatment, others will want similar exceptions, and export controls start looking less like a rules regime and more like a negotiation. Apple's lawsuit against OpenAI lands as more than a talent poaching complaint. Apple is saying this reached into hardware designs, proprietary parts, and server access, with one engineer allegedly using an unreturned MacBook to pull internal materials. If those allegations hold up, this is not normal aggressive recruiting, it's potentially theft of strategic IP. What's notable is the battlefield. For a while, AI competition was narrated as model quality, benchmark scores, and training scale. This suit underlines that device design, custom silicon, sensors, thermals, and on-device integration are now part of the moat. That makes sense. If AI moves into consumer hardware, the winning stack may depend less on who has the flashiest model demo and more on who can ship tightly integrated products at scale. One caution, though. Complaints are advocacy documents. Apple is making its strongest version of events at the outset. The broad strategic takeaway is solid, even if some specific allegations get narrowed later. Hardware IP is becoming central enough that companies are willing to litigate, like it's existential. The token economics story is one of the clearest examples of AI markets running hotter than their long-term business logic. If a $20 subscription is delivering hundreds of dollars of token equivalent usage to heavy users, that's not a stable equilibrium. It's customer acquisition, competitive positioning, and maybe a little strategic theater. For users, it's great while it lasts. For the companies, the bet is that subsidized abundance builds habit, workflow dependence, and maybe brand prestige before pricing tightens. The missing context is that average customers probably don't consume anything close to power user levels, so cross-subsidy inside the plan may partly explain the gap. Still, the headline point stands. These caps and giveaways look promotional, not structural. The likely correction isn't that AI access disappears, it's that the market starts charging more in line with actual inference cost, or segments users much more aggressively by workload. When that happens, a lot of apparent demand may turn out to be price-sensitive experimentation. That connects directly to the argument from Satya Nadella, Alex Karp, and others that the race may be shifting from giant frontier models toward architectures that deliver more intelligence per dollar. This isn't saying bigger models stop mattering. It's saying commercial value may hinge on efficiency faster than many people expected, because most real buyers care about reliability, latency, and cost more than leaderboard mystique. That also explains why some analysts think returns could flow disproportionately to infrastructure and hardware layers. If model makers compete away margin through subsidies and lower-cost inference, then the scarce assets may be the chips, memory, networking, and data center plumbing underneath. That thesis is not guaranteed. Efficient models could also widen the market so much that application and model companies still win huge. But it's one of the better supported cautions against assuming frontier model prestige automatically converts into the best economics. The KPMG and UT Austin study is useful because it shifts the discussion from abstract capability to observed behavior at scale across 1.4 million workplace interactions. The highest impact users weren't just writing better prompts, they were treating AI like a reasoning partner, framing the problem, iterating, checking, refining, and folding the output back into a workflow. That sounds almost obvious once stated, but it's important because it means gains may depend less on rare expert genius and more on trainable work habits. If collaborative use patterns are teachable, then organizations don't need to wait for the next model leap to improve outcomes. They can train people now on decomposition, verification, and iterative problem framing. The trade-off is time. Partnership-style use is often slower than one-shot prompting, but if it produces materially better judgment and workflow integration, it may be where the real productivity gains come from. Meta's brief image generation feature, which let Instagram users tag people so models could pull public photos, got rolled back almost immediately after backlash. That's a fast market signal. The lesson isn't that people reject all AI image features, it's narrower and more useful. Many users draw a hard line at systems that feel like they are operationalizing personal likeness without meaningful social consent, even when the source photos are technically public. And then, at the hardware layer, SK Hynix's huge US IPO and strong post-listing jump, even against a weak semiconductor backdrop, suggest investors still believe AI memory demand is special enough to overpower broader sector softness. The warning about a severe 2027 memory crunch could be self-interested, since chip executives always have incentives to emphasize future scarcity while justifying capacity expansion. But it also fits the wider story. If AI keeps scaling in deployment, memory becomes a bottleneck, not a side note. That pairs neatly with everything else here. Policy fights, model economics, privacy limits, even enterprise adoption, all keep pointing back to infrastructure constraints and control points. That's the through line this week. AI still looks like software on the surface, but the real leverage keeps showing up in chips, rules, and workflow habits. Thanks for listening to Podkey Slopcast. This episode was generated by Podkey. Create your own at podkey.fm.